Now, midterms are supposed to be challenging because they're supposed to be a rigorous way of measuring the knowledge that you've gained and the skills that you've gained since the beginning of the course. Okay, but I've heard from a lot of people that because of the switch to online exams, a lot of the challenge of some midterms seems to be that the questions are convoluted and strange. So maybe having to rewrite the questions to be formatted for an online setting results in questions that don't make any sense. And so my hope is that in this course, the midterm is challenging, certainly, but that the challenge comes from the material, not from the question being confusing. And so to that end, I've posted, as for the sake of general guidance, last year's paper practice exam, but I've also made up a sort of a sample exam with a few short questions on Connex, so you can go through and learn how to use the Connex test and quiz tool. So that part won't be a surprise. Because we have to use different styles of questions for this kind of exam, because people have different tools than they would have if they were writing the exam on paper, we have to use different kinds of questions. Not just like use an online test system, but also ask the questions in a different way. So I want to use this video to go through that new style of question so that even though they'll be challenging, the style that we use shouldn't be a surprise when we get there. And you can ask any questions about how to interpret these sample questions before the exam itself. So one thing to note is that some of the questions I've put on the Connex practice exam are actually harder than ones you can expect to get on the real midterm. And that's just so there's no sense I'm pulling any punches. I want to make it clear that we can ask challenging questions. We've designed the exam so that nobody's going to get swamped with like 40 really challenging questions, but you should expect, as in any midterm, there are those questions designed to separate the A's from the A pluses. And so we'll go over a couple of those as well. We'll see that if you tackle them methodically, I think they're still doable, but just like with any other exam, maybe there are a few questions that you might want to put off and do at the end or something to make sure you can pick up as many marks as you can elsewhere. Okay, so the first style of question that we're going to see quite a few of is the old-fashioned expression evaluation question. So here's a setup, some variables with types, and we want to produce the resulting value of z after we've executed that expression. Now, all of the questions on the midterm will be designed so that you can complete them by hand. You should not actually need to use JupyterHub or a compiler to complete them. You shouldn't need to. There are questions that say, trace this code by hand. However, if you want, you are allowed to use whatever tools inside of JupyterHub that you need, or notes you've written yourself, or books, or stuff online, as long as you don't use any interactive online tools except for Connex and JupyterHub. So you can't use certainly any sites where you post questions or anything like that, or any other online tools to help you answer, but you are allowed to use JupyterHub if you want, even for questions that ask you to do things by hand. On the other hand, you might discover that doing so just eats up time and doesn't necessarily help you. So the midterm has been designed and optimized to be done by hand. So this question here is asking what's the value of z? And you might notice because there's different types involved, we should watch out for typing shenanigans. But other than that, we're just doing the same style of example I've done in a lot of previous videos. We just plug in the numbers and see what comes out. So the value of a here is 19, and that's an int. The value of b is 6, and that's an int. Int plus int equals int. And 19 plus 6 equals 25. And then the next thing we have to do is to divide that by the value of b, which is 6, which is an int. And of course, int divided by int is int. There it is. You're going to see something about integer division on an exam. So here's the one we get on the practice exam. So 25 divided by 6, if the result has to be an int, will actually just come out to be 4. And then I get b, which is 6 times that, so b is an int. Int times int equals int, and the result is the integer 24, which I assigned to z. Now z is a double. When you type your answer into Connex, you can type 24. I guess you could type 24.0 if you want. We're going to use a bit of automation for the questions that take a numerical answer, but under no circumstances do you deserve to lose marks because you write the correct number. If you write 24.0 and the answer is just 24, Connex shouldn't mark you down for that, but in the event that it does, we will give the marks back. It's not reasonable to mark you down because automation doesn't work properly. So the answer here is 24. Here's a different example, and this one is a bit of a tough one. It's tricky because it requires a different thought process than we're used to. So here, you're given the value of z, and you have to find the initial value of b such that this works. Now, to be clear, there could be more than one right answer. Any answer you come up with that meets the criteria, that produces the answer that we want, is correct, and you will get the marks for it in the long run. Hopefully you get the marks for it in the initial marking, but if you notice a mistake and you can prove to us that your answer does work, then you'll get the mark for it. So here, the first thing is we have multiple operators at once, and questions are often designed to look tricky, and therefore it's always a good idea, even if we think it's obvious, to draw in those imaginary brackets. I have the precedence table over here on the side. I won't flip between windows, but if I look at the precedence table, I'll discover that this operator, the modulo operator, and the multiplication operator are tied. And that means that we have to consult the associativity to figure out which order to do them. And it's this way. The imaginary brackets look like this. You might notice the typesetting of the question tries to nudge you into doing this first, but that's wrong. And you can't trust the question. You can only trust what you know about the language and the precedence and the associativity. So it works like this. Okay, so the final result is 21. This expression results in the number 21. And I'm going to read this because we're trying to reverse engineer what the number b was. Well, okay, something times b equals 21. So what, in integers, what could that possibly be? Okay, so here are some things I can think of that multiply to 21. 3 times 7. 7 times 3. And then 1 times 21 and 21 times 1. And you could just try all of those different values of b. You might be able to observe pretty early on that it's pretty unlikely that b is equal to 1, because that would make the modulo not really do what we want. It's pretty unlikely that b is equal to 21, because if I tried out 10 modulo 21, it would come out to 10. So that's not going to work either. Okay, so b is probably either 3 or 7. So let's just give each of those a try. I'm going to back this up. Okay, so let's say that b is equal to 3. If b is equal to 3, then we've got, so the value of a is 10 here. So I've got 10 modulo 3 times 3. Okay, so 10 modulo 3 is 1. 1 times 3 is not 21. So I don't think that b is 3. Okay, so what's the other option? Well, b could be equal to 7. So we've got 10 modulo 7 times 7. So what is 10 modulo 7? Well, as it happens, it's 3. Okay, so if I give b the value 7, then I get the right answer. Is that the only right answer? Maybe not. There could be other values of b, for all I know, that give the right answer. But in this case, if Connex asks you to fill in the blank and you give anything that works, you'll get the mark. And so here, the value is 7. And here's a disgusting one. And you should expect you probably will get 1 or 2 disgusting questions like this on the actual midterm. This one's disgusting in more ways than one. Usually we design midterm questions to only be disgusting in one way at a time. But we need to be able to tackle a question, even one this ugly. So what's going on here? Well, we have to reverse engineer the value of b again. But also, the question has no brackets, and it's got a whole ton of different operators, and, you know, it's a mess. So we need to work backwards, but before we do anything, let's try and work out where those imaginary brackets are. So we go grab the precedence table, and we observe that the highest precedence operator is the logical not operator of the ones that's used here. So it comes first. It turns out that logical and logical or are both below operators like these two, equals and not equals. And so those come next. So then I'll put brackets around the equals. There's the brackets around the equals. And here are a chain of 2, so equals followed by not equals. And in the table, those are tied. So we have to consult the associativity to know how to break those up. And so it turns out in this case, we go left to right, and so we end up with this. Okay, and then finally, how do we break up logical or and logical and? And it turns out that logical and has higher precedence, and that means that this and this are the two operands to logical or. So the result, the final value of z is 1, which is, well, logical or will produce a 1 if either or both of its operands evaluate to true. So let's see what we can do here. First, we know the value of a. Let's see if that can help us with anything. Okay, so a equals 1. Well, let's just plug it 1 in everywhere we were using a. Okay, so I've got this, logical not of 1. Logical not takes its operand and flips its truth value. True becomes false, false becomes true. So 1 is true, so flipping that gives us a 0. Now, think about this. We've got something and 0. It doesn't even matter what this thing is. Anything and 0 will produce the value 0. So I've got 0 or something, and the result that I get out of that or is a 1. And we know that or only gives us a 1 if either or both of its operands evaluates to true. And because this 0 definitely doesn't evaluate to true, that means that this thing over here has to evaluate to true. And so actually, even before I work out the value of b, I can just ignore this entire left-hand side, and I can just start working on what's happening over on the right. Okay, so 1 equals 1. Okay, that's true. So I've got 1 and something. And I know that for this and to give me a true result, because I know that I need this entire expression to come out with a 1, for and to give me a true result, this has to evaluate to true. So what I want is I would like b, I compare b to the value 6, and then I say, is the result equal to or not equal to 0? And I want to get a 1 out of this expression. I want the result of this to be not equal to 0. In other words, I don't want it to be false, or I do want it to be true. I want it to be true that b is equal to 6. So it sounds a lot to me like the value of b is supposed to be 6. So let's try this out. So if b is 6, okay, so is 6 equal to 6? Yes. So this is 1. Is 1 not equal to 0? Yes. So this is 1. And then I've got 1 and 1, which is true, and then that gives me the value true in this right-hand expression. So that's the correct answer. B is equal to 6. This is a question where you might want to put, if you see one this disgusting, that might be one to put off until the end if it's hard to hack away at it. Because in these fill-in-the-blank style questions, each blank is just worth 1 mark. So it's worth less than stuff like a code rating question. So it's not as much of a payoff, and so if it seems a bit tedious, it might be one to prioritize a little lower. Here's another disgusting one. This one is testing the use, it's testing, I think, a combination of a little bit of precedence stuff, but mostly just and or. There are a lot of brackets, but we can add a few more. So you may not need to add these because you might be used to combining together conditional expressions with and, but it's good to put them in anyway, just so we don't get confused. So the less than and greater than operators have higher precedence than and or. We also know that and has higher precedence than or. So we end up with this. And I think now we have brackets in all the right places. So what we want is the result to be true, to be 1. And that means that this has to be true. Okay, so a plus b has to be greater than 8 because it goes into a logical and z ends up with the value true. So if a plus b is greater than or equal to 8, that means, okay, so a is 6. 6 plus b has to be greater than 8. And that sounds to me like saying that b has to be at least equal to 3. Because if b is equal to 2, then 6 plus b is 8, which isn't greater than 8. And if b is equal to 1, then 6 plus b is 7, which isn't greater than 8, and so on. So b has to be at least equal to 3. And then this whole thing has to evaluate to true. And we notice that because this whole thing is a logical or, either this has to be true, or this has to be true, or both. So let's see what we can do with those two things. Okay, so the second one here is a greater than 9. Okay, 6 greater than, okay, wait a minute, 6 is not greater than 9, which means this whole thing here is false, and that means that this and is also false. Which means that if either this or this have to be true, well, this is not true. So I can only focus now on this middle clause here. Okay, so is 6 less than 7? A is the value 6? Yes, so this is true. And I need this to also be true for my result to be true because of the logical and. B is less than 4. Okay, so if B is greater than or equal to 3 and B is less than 4, it sounds a lot like B should be equal to 3. It seems like that'll work. And you can always try that by, let's see if I can circle stuff today. You can always try that by plugging everything in. So let's see. A is 6 and B is 3. So that's 9. And so is 9 greater than 8? Yes, true. Is A less than 7? So A is 6, that's true. Is B less than 4? B is 3, so that's true. And then we'll put brackets back there. Okay, so what about this? A is greater than 9. Is 6 greater than 9? That's false. Is B less than 2? Okay, it happens that that's actually also false. So false and false. Some bad ampersands. That's false. And this we've got 1 and 1, which is 1. So the value of 1 or 0, true or false, is true. or 1. And then finally, this one and this one give us the value 1. So 3 does work. We were able to deduce what it was and then just verify it quickly and make sure we weren't incorrect. Okay, but that's ugly. There are a few more ugly ones, but none that I think are so involved. They're ugly, but they don't take as long. And that brings us to this style of question. This is also an expression question, but this is one that's testing our knowledge of those advanced assignment operators. So we've got, there's A, there's B, and we'll draw Z. So it's always good to use a diagram whenever you see plus plus or minus minus because it's easy to get thrown off by those. So we don't know the value of A. We also don't know the resulting value of B. We know that something happens involving Z, A, and B. And then A, B, and Z all have values after that. But we need to fill in both of those blanks. The way I'm going to handle this is I'm going to start by trying to figure out the initial value of A. Because if I know that, I could just work out the resulting value of B by plugging everything in. Okay, so I know that the initial value of B is 13. I also know that the only thing I ever actually do with A is this A++ operation. And that adds 1 to A. And it also does something else in the context of Z, but the only thing this does to A is add 1 to it. Okay, so when I'm done adding 1 to A, the value of A is 9. Okay, so I think A was 8 to begin with. Okay, so A is 8. Let's try out 8. So if A is 8 and B is 13, then what happens? Well, A++ says add 1 to A and then send back the old value of A, which is 8. So then the old value is 8, and I add 1, which gives me 9. Minus B. That says subtract 1 from B and send back the new value of B. So B was 13, I subtract 1, that gives me 12, and then 8, and then I've got the result of minus B is 12. And so 8 plus 12 is 20. And that looks about right. And the eventual value of B is then 12. So I fill that in. Actually, I'm going to just uncircle that. So the value of Z is 20 like I expected, and the eventual value of B is 12. So the correct answer here is A is 8, B is 12. Is that the only correct answer? I think so, but if it weren't, and you give anything that's correct, you will get those marks eventually. Then there's this one, and here you have 2 unknowns up at the top, but you have the resulting values of all 3 things. So here's A, here's B, and here's Z. Int, and double. Okay, so the initial value of A is something, and the initial value of B is something. And then we do this operation. And notice that in this operation, the only thing I ever do with A, and actually I guess we should add our brackets first. So the first thing I would do is the post increment. That's the highest precedence operation. Then I do this because equals has the single equal sign has lower precedence than addition. And then I finally do this. Okay, so the only thing I ever do with A in this expression is add 1 to it. And when I'm done adding 1, the value is 3. So I think A probably started with the value 2. So we'll enter 2 as the initial value of A. Okay, so then when I do this operation, I add 1 to A and I send back the old value of A. And then the resulting value of A will be 3. Okay, that's good because that's what we expect. So then I say, okay, I want to take B plus 2, and I want the resulting value, which I assign to B, because we have this equal sign here, I want that to be 12. Well, let's see, what plus 2 equals 12? How about 10? So if B's initial value is 10, then I've got 10 plus 2, that's 12, and then I'm writing B equals 12, and so that assigns the value 12 to B. And what comes out of that expression is the new value of B, which is 12. And so I end up assigning the value, so that means this whole expression has the value 12, and I assign the value 12 to Z. And so it looks like that worked out. It looks like everything added up there, and I end up with my initial value of A being 2, and my initial value of B being 10. Now, to shift gears a bit, let's stop talking about expressions and start talking a bit about types. So in my little slide thing, the number of dashes here doesn't necessarily mean we're not playing hangman or something. This is just going to be any type. So the goal here is to fill in this blank type such that everything else adds up. So we can't change anything else. And what we notice is that A is assigned this value. Now a could still have type int. It doesn't necessarily have to have type double if I'm assigning it 2.5, because we know that it's completely valid, even though it's a bit strange, to write something like this. But if we write something like this, the ultimate value of x isn't 10.6, it's just 10. So the question is, what type should we use for a to get this result? And what I would probably start by doing here is filling in, just fill in the value of b everywhere. So b is a double, and its value is 4. And the choice is basically either a is an int or a is a float or a double. That's pretty much it. And the question we have to answer is, do we want that 0.5? If we make a an int, then a just becomes 2. If we make a float or double, then a actually does have the value 2.5. So let's see what happens if a is 2.5. So that means that a is a float or double. Okay, so that means that we have z is equal to, in that case, 2.5 times 2.5 plus 4. 2.5 plus 4 is 6.5. 2.5 times 6.5 is not equal to 12. So I don't think that a has a float or double type. Okay, that's probably not going to work. What about int? Int a equals 2.5. Well, if I say int a, the real value of a will just be 2. So let's try that out. So int a. Okay, so if a is an int, then it gets assigned the value 2. So I have 2 plus 4, and that's all times 2. 2 plus 4 is 6. That times 2 is 12, and so I get this result. And so the correct answer in this case for this missing type is int. Here's another example. This should be a familiar one to us. Another way of seeing that same thing we're pretty much expected to see on a first programming midterm in a language like C. So I'm running this expression, a is an int. It's the int 6, and I'm dividing it by something, and I'm storing the result in a double. And the result that I get, so b has the value 10. The result that I get is int divided by something, and I get 0.6. And I know that if b has a type, if I actually had the type int here, then I would have int over int, which would be the value 0, because I can't store 0.6 in an int. So that's a sign that the type of b can't be int. The only option for the type of b would be float or double. So I guess there are two options. You could say float or double, but it has to be one of those. It can't be int, because it has to be a real valued floating point type. Now the tracing. So on the actual practice midterm, you'll see that this is all on one page, but because of the way this works, I've split the code and the questions about the code onto 2 pages. So what this tracing question says is, in the past, midterms would say something like, trace through the code by hand, give all the output. But I can't easily ask that this year because it doesn't really test anything, because the logical thing to do is just to run the code yourself. And so there's no point in having a question about code tracing if you can just run it yourself and then get the answer. We need to know how to do code tracing by hand in this course. It's a key outcome, because when code doesn't work, tracing through it by hand is often the only way to figure that out. So the way that we've decided to test that is instead to give tracing questions that are conditional. And this is actually, there's precedent for this, because when you're tracing through your code because it's broken, you often have the same mindset. You keep tracing your code until you notice something weird happening. So what this says is, trace through the code by hand, draw your diagram or whatever you want to do, and stop immediately as soon as any variable, so an actual variable where we're storing a value, is assigned a value that's at least equal to 7, a value greater than or equal to 7. To be clear, this question is not saying as soon as you see the number 7, stop. It's saying as soon as you assign that into a variable, stop. So put the value in the variable and then stop tracing immediately. So let's try tracing through this. Okay, so I enter in on line number 2. I'm inside of main. I'm going to draw myself a big scoping box because I can see that there's obviously some scoping shenanigans possible, because I've got a while loop, and then inside that, another while loop. So there's main, and I create 3 variables, a, b, and c. So there's a, it's an int. There's b, it's an int. And then there's c, it's an int. Okay, line 3. I assign the value 2 to a, and then on line 4, the value 2 to b, and then on line 5, negative 999 to c. And so I hit line number 6, and I ask the question, is b equal to 0? And so, well, I should phrase that differently. I ask, is it true that b is not equal to 0? And the answer to that question is yes. So I open up a scope for my while loop, I'm actually going to call this while, and I'm going to write 6 because it's on line number 6. Because I'm noticing in the future on line number 10, I might have another while loop to deal with. Okay, so I open up my while loop, and then it says a equals a plus 3. Okay, so I actually have to work this out. So what's the value of a? In this scope, I have nothing called a, so I leave, and then I find the value of a out here. It has the value 2. So a equals 2 plus 3. Well, that's, okay, 2 plus 3 is the integer 5, and so I assign that to my variable a. Okay, and then we'll just clean this up. b, so I go looking for b. There's nothing called b in here. I go looking outside. There's the value of b. Okay, b equals a modulo 7. So what I want is 5 modulo 7. And the answer to that is 5. The nearest multiple of 7 less than or equal to 5 is 0, and so 5 mod 7 is 5. And then I say on line 9, create a new value c, there's int c, and set it equal to b. Okay, so where's b? I guess it's still got the value 5. There we go. Int c equals b. Okay, now I ask the question, is a less than b? And the answer here is no. So in this case, a is 5 and b is 5. Is 5 less than 5? No. And so I just skip over this. I don't do any of this while loop. The answer was no. And so I get to line number 14. That's a closing curly bracket. And so I wipe this out. Actually, this time I'm going to try circling it because I might need the space in a minute. Yeah. I am definitely improving at this. Okay, so I go back up to line number 6. I ask the question again. Is it true that b is not equal to 0? So b has got the value 5. So yes, that is true. So I enter my loop again. So I draw a nice new scoping box for it. It's the while loop on line 6. Okay. Line number 7, a equals a plus 3. I go looking for a. Well, there is nothing called a in here, so I get the one from outside. I'm setting this to 5 plus 3, which is 8. And I clean this up again. And then I stop immediately. I have a variable whose value is greater than or equal to 7, and so I stop right here. And notice how I'm currently inside this while loop. So this is my current scope. I just freeze my diagram because I've reached the criteria that it's set for me to stop tracing. Okay, so I stop and then I take a look at the questions to answer. The questions are, answer these questions based on the state of the program at the point I stopped tracing. So I don't continue. It doesn't matter what the program does. When the program finishes, if the program finishes, I stop as soon as this condition is satisfied. Okay, so what's the value of a? At the current point in the program, I am sitting inside of this scope here. So I go looking for a value of the variable a. Okay, nothing there. Oh, it's 8. What's the value of the variable b? Okay, same story. Nothing called b in here. I go looking outside, and its value is 5. And then there's this weird thing. Okay, if I put this statement, print the value c, at the exact point I stopped tracing, what would the output be? So where did I stop tracing? Whoops, wrong direction. I stopped tracing right after line number 7. I finished line 7, and that's where a got the value 8. So if I put right here the statement print f, and I print out the value of c, what would I get? Well, let's see. In this scope, is there something called c? Not right now. Okay, so I leave the scope, and I get the value negative 999. So the answer to this is negative 999. At the point where I stop tracing, how many different variables named c currently exist? So we know that there can be lots of places in a program where variables with the same name can exist. The question here is asking, if I look at the state of my program right where I stopped, how many things called c currently exist? Okay, well, let's see. Nothing in here called c, one thing out here called c, and so the answer is just 1. So the key thing to understand with these tracing questions is there's some condition. It could be when a variable gets the value greater than or equal to 7, a variable turns negative, a variable gets the value 0. As soon as that condition is met, you stop immediately. You do not continue tracing because the subsequent questions are all based on the state of the program at that moment. Now, as I said, it says trace it by hand. You're welcome to try and use JupyterHub or code or compilers to help you with this. But keep in mind, my belief is that generally speaking, going through by hand may well be faster than what you'd have to do to get JupyterHub or a compiler to help you out with a question like this. But you're welcome to do that. There's no requirement that you do it my way, as long as you get the right answer. Okay, so same thing, but this is a question involving function calls. And so here the condition is stop tracing immediately when any variable is assigned the value 6. So a variable can be assigned the value 7 or 5 or negative 5 million or 5 million, but as soon as something gets the exact value 6, as soon as that is assigned to a variable in the program, then I stop immediately. Okay, so I begin tracing on the beginning of main, which is line number 12. I'll draw myself a nice scoping box. I will be mindful that I'm probably going to want scoping boxes for other functions, so I'll draw, that's probably a bit too small. I'll draw maybe this one. Okay, line number 12, make a variable called a, give it the value 17. There it is. Line 13, I ask the question, is a, which is currently 17, greater than 0? The answer is yes, and so I make myself a nested scope for that if statement. All right. And line number 14, create a variable a and set its value to 5. And so here I now have another variable in my program named a. But remember that because of the way scopes work, that is unambiguous. Inside this scope, the value of a is the value of this variable here, which is currently 5. Now I make a variable called b, which has a value 3. And then line number 16, I have to evaluate this expression. I'm going to want to do a function call, but before I do that, I want to sub in my arguments. So as of line 16, what is the value of the expression b? It looks like it's the number 3, so I sub that in. What is the value of the expression a? It's the number 5. All right, so I have my arguments. I'm ready to do my function call. So I draw a box, I draw a scoping box for my function. It's going to be the function f. There it is. There we go, underline it. And then, of course, I create, before I can start executing, I have to create a box on my diagram for each of the parameters of f. There's a, there's b. And the parameters just go in left to right. So the first thing I passed in, the number 3, that becomes a. The second thing becomes b. Okay, so a has the value 3 here, b has the value 5. Notice how this is just like that ugly example from a few weeks ago. There are lots of variables called a and b, and they seem to be getting twisted around. As long as we keep track and we trust our diagram, the diagram can do this work for us. So I've set up my box for b, my scoping box, or for f. It's got its variables a and b, its parameters. I've sent in the values. Now I can begin executing the function f. And the very first thing that happens on line 7 is I call the function g. So inside this scope, what is the value of the expression a? It's 3. Okay, so I call g with the argument 3. So I draw a scoping box for g somewhere. I'll just do it over here. There's g. And it has a single parameter whose name is b, and we assign that the value 3. So now I've got a box for each of the parameters of g all set up, and I've put in their values, and so I can begin executing g. The first line of g says create a variable called a. I guess I should have made a smaller box for b. So I create a variable called a, and its value will be 2. And then I return the value b minus a. So what's b? In this scope, the value of b is 3, and the value of a is 2. So that means that I return the value 1. So I make a note of that return value. I go down to where I called the function, that's this line here, line number 7, and I sub in the return value 1 for the actual function call. And then g ends. And so I destroy the scope. I make sure there's no way I can accidentally see those values again because they would just confuse me. It is gone. Okay, so I'm back in f. I return to where I was in f. I'm now back in this scope, and I set b to have the value 1. Okay, so b has the value 1. There we go. A equals b plus 6. So remember, we stop as soon as a variable is assigned the value 6, as soon as it is set to the value 6. In this case, the number 6 showing up doesn't mean we've met that criteria yet. Okay, so a equals b plus 6. Okay, so, well, b, the current value of b is 1. So 1 plus 6 equals 7. Okay, so I set, in this scope, a is this thing. I set it to 7. All right. I'm going to clean this up a little bit. Okay, the next line, line number 9, is return b. So I evaluate the expression b. In this scope, the expression b has the value 1, and so I'm going to return the value 1. And so I go back to where I called the function that I'm in, the function f, and I sub in for the function call the return value of 1. And then the function f ends, and its scope is destroyed. It is gone. And now I go back to main. So in main, I was just in the middle of evaluating line number 16. And line number 16 now says 5 plus 1. And of course, that is the value 6. And so I assign that to, inside this if statement on line 16, I'm in this scope. I assign that to a, and then I stop immediately. Now that a has been assigned a value 6, I've met the criteria of the question, and so I am done. And then I go look at the follow-up questions. Okay, what is the line number of the last line executed? That is to say, the line where you stop tracing, the assignment statement that caused the condition to be met. Well, here, I was sitting on line number 16. So the correct answer for this is I stopped at line number 16. What is the name of the function that was currently executing at the point where I stopped tracing? Now, this is a terminology thing. I'm actually expecting some people to try and argue with me about after the midterm about this kind of question. But this actually is unambiguous, and that's why we have to be able to answer it. Currently executing. When I did that last assignment, when I modified the value of a in here, what function was I in? I was in main. It's true, I'll just clean up the code so we can look at it a bit more. It's true that on line 16, I did call a function, f. I did, run a function. But at the time when I stopped tracing, that function was long over. I was still in main assigning a value to a variable in main. And that means on line 16, I am in the function main. And then finally, if I try and print out the value of b at that point in the code, so if I put a statement printf the value of b right here on line 16, I'm still inside the scope of the if statement, what do I print out? In this case, I would get the value 3. And that's the answer for that question. And so the key thing here is to make sure that you keep track of what you're doing and you stop immediately once the condition is met. And each question might have a slightly different condition. The previous one said greater than or equal to 7. This one said any value equal to 6. There could be lots of different conditions. As soon as it is met, as soon as a variable is assigned or set to the value 6, we stop immediately. And then there's this. So I just want to prove a point about this, which is the follow-up questions are going to be pretty easy. What's the value of A? What's the value of B? What's the value of C? I want to head off any criticism from later now by going through an example of this form. So let's trace through this. We're going to stop immediately when any variable is set to the value 6. Okay, so I first make up a scoping box for main. There we go. And then I start on line number 3. So line 3 says make a variable called a. It's an int. Set it to the value 2. And then I've got here on line number 4, make a variable b. And on line number 5, I make a variable c, which is equal to 3. Line 6, while 2 plus 2 is equal to 4. So that's weird. Am I allowed to do that? Yes. I can write any expression that I want. Is this an infinite loop? Yes, it is. Does that mean that if I actually ran this program, it would never finish? That's exactly what it means. Can I still answer a tracing question about it? You bet. So we often have to trace code full of infinite loops, because if we break our code and it has an infinite loop, we have to be able to fix it. So it's completely legitimate to give you code that never would finish and tell you to trace through it, as long as I give you a way of stopping once some condition is met. So I ask the question, does 2 plus 2 equal 4? And the answer at the moment is yes. So I go inside, I open up a scope for my while loop, and then I say a equals a plus b. Okay, so the while loop has no variables of its own, so I'm going to be going outside for all of its variables. A has the value 2, b has the value 1. 2 plus 1 is 3. So I set a to have the value 3. All right. Next line, line 8. B equals C plus B. So C has the value 3, B has the value 1. So that means I set B to be the sum of those two things, which is 4. C equals C plus A. C is 3, A is 3, and so I set C to be the value 6. So I go over here, I modify C to have the value 6, and then I stop. I have met the criteria. Once I'm done that statement, once C has the value 6, it has been assigned the value 6, I stop immediately after that's done. Okay, so I stop and I answer the questions. What is the value of A? So at this point in the program where I stopped, there's only one variable called A, so there's no need for any complicated phrasing like what happens if I put a printf statement. It's unambiguous. The value of A is 3. What's the value of B? The value of B is 4. And what's the value of C? The value of C is 6. And so, as I said before, it's perfectly valid to ask people to trace through code that does very strange things. It's actually also worth considering that we often write code that deliberately contains infinite loops. And that's also valid. For example, the code that reads characters from the user. It's valid to use infinite loops, and we need to know how to trace code that has them. It's also worth considering, despite the fact this code would never have finished, I was able to finish the tracing question in about, 7 statements worth of code.